So in this video, I'm going to focus on two aspects of the blood concerning diabetes and glucose. They're going to be the red blood cells and glycation. So I'm going to go left to right, top to bottom, and again this video is broken up primarily into two segments, and all the vitamins and minerals are circled in orange. So those are the highlights of the video for the kind of the takeaway points. Alright, so let's carry on. So the blood, generally speaking, has a pH of about 7.4. Now pH, again, is critical for proper protein function and overall chemistry of the environment. So you got to make sure that your pH is pretty much around 7.4 for the blood to be operating properly. And in my opinion, the way to help manage the proper pH is to get your minerals. This is potassium, calcium, sodium, magnesium, and the trace minerals. So I'm going to leave in the description box below some of the vitamins and minerals that I would recommend, and I'll leave the products in the description box below. So anyways, get your minerals to help you optimize your blood pH. Okay, so inside the blood we have red blood cells, and they're called erythrocytes. And I just have RBC to highlight as an acronym for red blood cells. On any given day, there's roughly 25 trillion of these red blood cells circulating around in our blood, and they are the most abundant cell in the blood. They transport oxygen and carbon dioxide. And one of the things here I want to highlight here, this is why I'm focusing on it, is because red blood cells rapidly pull glucose out of the blood for us. Now they're able to do that so effectively, more so than with other sugars, is because they have something called a GLUT1 transporter. So GLUT1 is glucose transporter, and there's one, which is the first one. So there's a couple of different glucose transporters in our body. So red blood cells use this glucose 1 transporter that I have here in blue. So this is around the cell membrane. And they make up about 2% of each red blood cells. So we have about 25 trillion in our blood again. So we have a lot of these GLUT1 transporters floating around, helping us pull glucose out of our bloodstream. Now to highlight here, it is a glycoprotein. And again, glycoproteins are both carbohydrates and proteins. So it's a protein that requires carbohydrates to function properly. And I think I just mentioned, but the cell membrane makes up about 2% is made up of about 2% of these GLUT1 transporters. Also, red blood cells, and epithelial cells also have something called a glycocalyx. And this glycocalyx is like a mucus coat around the red blood cell. And again, this is a carbohydrate protein and also a carbohydrate lipid. Now these glycocalyx help with cell-to-cell communication, cell-to-cell adhesion, and they're found outside of every red blood cell. So there's three ways that I illustrate that we need carbohydrates in our body for us to function correctly. So for red, we need vitamin B-12 and folate to make red blood cells. So these are the two vitamins here that you want to kind of be focused on to make sure that you're making enough of your red blood cells. Okay, so how do we stimulate the secretion of more red blood cells? Well, when tissues oxygen levels drop to a certain point, a signal is sent to the kidneys to release erythropoietin. Now that's a growth hormone, so I just have it highlighted as EPO, and that's a growth hormone. And when this growth hormone is released, it increases the production of red blood cells. And again, this is a carbohydrate protein or hormone. So again, this is another example of how we use carbohydrates to function properly. So again, we have erythropoietin that helps stimulate the production and synthesis of red blood cells. On a footnote here, Lance Armstrong was accused of injecting erythropoietin as a performance enhancer when he was competitively cycling because it also stimulates the consumption of oxygen and the use of oxygen, because red blood cells transport oxygen for us. So, highlight here on this side, we need carbohydrates. These are carbohydrate complexes, these carbohydrate lipids and proteins. So these are how we use carbohydrates. Make sure that when you get a blood test, see if you can have your doctor check out how many red blood cells you have and seeing if they're healthy or not. Most abundant cell in the blood is the red blood cell. They help manage our glucose levels because they pull glucose out of our blood. Red blood cells, B-12, folate, and then for the pH, make sure you're getting enough of your minerals and trace minerals. Okay, so moving on to this part of the board. Now the downside of glucose is something called glycation. Now that's when glucose binds to a protein that it's not supposed to. And when glucose binds to a protein it's not supposed to, it causes changes. This triangle indicates change. It changes the structure and the function of that protein, which could actually cause it to be useless. So this is glycation, when glucose and protein are bound together when they're not supposed to be. It causes the protein to lose functionality. What also happens, which is found with diabetics, is that it increases oxidized blood fat. And this glycation issue is common in red blood cells, specifically with diabetes. So this glycation, where this glucose binds to proteins associated with red blood cells. Now one of the issues here that has been highlighted in my textbook is that artificial sweeteners, or molecules that kind of look like glucose, can bind to this GLUT1 transporter. And when these chemicals bind to the GLUT1 transporter, it prevents the glucose from being absorbed by the red blood cell. So these artificial sweeteners, if you're taking them as a corrective measure for diabetes, be careful, because they may actually be interfering with you being able to pull the glucose out of your blood by the red blood cells by blocking this GLUT1 transporter. So just be cautious of artificial sweeteners for that. So how do we correct glycation? Vitamin C and magnesium have been shown to improve or lower glycation in blood and throughout the body. So vitamin C also reduces sorbitol accumulation in red blood cells. Vitamin C and magnesium also increases both glucose and lipid metabolism, so this will help lower your glucose levels. And it also reduces oxidative stress. So vitamin C and magnesium also reduce oxidative stress, which is an issue with diabetes. So you want to be making sure you're getting enough vitamin C and magnesium. And a footnote here with vitamin C is that vitamin C uses insulin to get into the tissues. And with diabetes, it's often common that insulin levels are relatively low in certain diabetics. So if you know you have low insulin levels, you really have to be ramping up your vitamin C intake so you don't suffer a deficiency. Okay, and also we have vitamin E. Now vitamin E reduces damaged cell membrane. It also increases insulin sensitivity, and again it reduces glycation, which would be the glucose protein binding. So again, two parts. Make sure your red blood cells are healthy and you have enough of them. Work with your doctor to see if you have enough healthy red blood cells. Remember, carbohydrates are not necessarily the enemy here. We need carbohydrates to function properly. Make sure you're getting enough of your minerals to help make sure your pH is right in your blood. Maybe see if your doctor can check your blood pH. And optimize your magnesium and vitamin C as well as vitamin E to help reduce glycation, again, which is glucose protein binding, non-specific glucose binding proteins. Okay, best of luck, and there you go.